Okay, I'll go on then. So let's see where to start. Maybe it's best to start at the bottom with the hypervisor host. So as I said, it's just a server running virtual machines. And all of those virtual machines, let me get my mouse pointer in here maybe. They are all connected to this OpenV switch over here. And OpenV switch, it's a Linux kernel module. It replaces the standard Linux bridge. So yeah, it's basically a network bridge, but the one thing it does that the Linux bridge does not do is OpenFlow, which we will get to in a minute. But in short, OpenFlow means, well, it's a protocol that you can use to tell OpenV switch or any OpenFlow switch what to do. And that's really how OpenVNET or most software-defined networking works. This is a good moment to start from. Whoops. This is a good moment to start from the top, actually. So the user will decide, like, okay, I want to put these two VMs in one network, I want to put these two in another one. And he will use a little client called VNCTL to tell OpenVNet about that. OpenVNet has a web API that's listening for HTTP requests. And so that means this doesn't have to be a laptop. You don't even have to use VNCTL. As long as you have a device that can send HTTP requests, you can talk to OpenVNet. And VNCTL is an extremely simple command line tool that just gives you a couple of commands and sends out HTTP requests. So I keep hitting the scroll bar on the right of my mouse pad. So the user tells OpenVNet he wants some networks. Then the web API will send a message to the VNet manager. And this thing, like, it has an overview of the whole system. Like, there's a hypervisor host over here, and there's a couple of more. And VNMGR will know how many there are, like which have which virtual machines, which have virtual machines, and which networks. It has like the whole picture, pretty much. And all of that is stored in a MySQL database. And then VNMGR will decide what needs to happen, and it will send messages to VNA over here, the VNet agent. And this is actually an OpenFlow controller, which I will also explain in a moment. And this thing will tell OpenVSwitch to basically change how it's handling network traffic. It will tell OpenVSwitch, like right now, these two are in a network, and these two are in another network. And VNet Edge up here, that's in case you want to connect other networks to OpenVNet. Let's say you have a legacy network that is just like some physical cable somewhere, or you have a cloud system with its own network that you want to connect to another system where you have OpenVNet installed. And this VNet Edge over here can create a layer 2 connection, which makes it look like the virtual network and the legacy network are like connected to the same switch. Like they have the same subnets, the same collision domain, all that stuff. That's actually what I demoed last time before my gaming presentation. Or was it after? I forget. And so I've been mentioning OpenFlow a little bit. The thing is, you have a lot of switches, routers, and network devices out on the market. Like Cisco makes a bunch of them. Then you have D-Link, and you have like more software implementations like the Linux bridge. And one thing they all do is like network traffic comes in, they make a decision, and network traffic goes out or gets dropped or rewritten or whatever. And that decision is made in flow tables. Probably different vendors have different names for flow tables, but it's all pretty much the same. Like packet comes in, it's matched against a certain amount of rules, like they look at its metadata, at all the headers, and then make a decision based on that. And flows is a word that OpenFlow uses. OpenFlow is a protocol, like a language, that network device vendors can implement to allow their flow tables to be changed on the fly. And the controller over here, that's a piece of software that, well, uses OpenFlow to talk to network switches and tell them to change their flow tables.
Is that different from the agent in the previous slide?
It is actually exactly the same.
Okay.
In OpenVNET's case, the OpenFlow controller is VNet agent. And the switch we use is OpenVSwitch. Sorry, I'm just gonna get my water bottle. Actually, the demo I'm gonna give today, I first came up with when I was presenting at the Trema Day event. And Trema is a framework for writing OpenFlow controllers in Ruby or C. In OpenVNet, we are using Trema. So they had invited us for a presentation, and I was only given 10 minutes actually there. So don't worry, I have enough time. And I thought, what the hell can I do in 10 minutes? So I decided to write a couple of scripts that send a bunch of messages to, well, HTTP requests to OpenVNet's API, and create a bunch of network configurations that way and show everybody, hey, within 10 minutes, I can make all kinds of different networks using OpenVNet. And then after I had done that, I was like, hey, wait a minute, this is really good documentation. So I started writing a bunch of documentation, and people on the mailing list might remember me real enthusiastically sending an email like, hey, I've got a presentation for you guys now. Like after I had written all this documentation, I wanted to show it and tell you guys about it. So that's what I'm doing right now. Yeah, you have a question?
I remember this. I clicked on it. What did you use for the documentation?
It's Smart Docs actually. It's OpenVNET.org. This is the documentation here. It's not playing well with my small window over here.
Yeah.
I'm gonna go to the installation guide afterwards.
Very nice.
Yeah. And these things I made in LibreOffice Draw. And the framework for the documentation itself is Smart Docs. If we have some time left at the end, I'll talk about them. So, let's see, where was I? So this is what we're going to be installing today. We're just going to take one virtual machine. I'm actually going to be running a virtual machine in my laptop that's running CentOS. Because currently, we only officially support CentOS. Like, OpenVNet will most likely run on other distributions, but we have not prepared any Debian packages or anything. We just have RPMs, and they are only tested on CentOS. And so, yeah, one CentOS VM, we're going to install the Web API, VNMGR, and VNA, all of the 3 parts of OpenVNet, and also the tiny VNCTL client that just sends HTTP requests. We will be creating 2 VMs in there and connect them to OpenVSwitch. So we'll have a tiny physical network in this case with 2 VMs, and on top of that, we're going to be creating a bunch of virtual networks. Can be a little bit hard to grasp how I refer to this as a physical network, because this is virtual, but from OpenVNet's point of view, it's this is the network that's in place where the traffic is really going to go through in reality. And then OpenVNet on top of this is going to be creating virtual networks. So yeah, I guess it's kind of like nested virtualization in this case. But this is actually the most common usage of OpenVNet, because usually you'd want to use this in a cloud system where you have a bunch of VMs that you want to put in any networks that you can change on the fly. I'm hoping it'll get a bit more clear when we actually get to the demo, which is right now, as I put in our mascot character, Wakame-chan. So. And actually, I shouldn't have gone immediately to openvnet.org because we've recently, I made a new company website that I thought I'd show off a little bit. I know some of you have already seen it. There's our OpenVNet page, and if you click on documentation here.
Did you do the website?
I did most of the content, but we hired a designer.
Mm.
Actually, the designer we hired, Stephen David Smith. Will he come up? That's not his picture, but it is this guy. He is actually quite ashamed of this website because he made it years ago and has had so many clients that he couldn't update it. So our website is a better example of what he can do. So let's get to the installation guide. So actually, I already have the CentOS machine running over here. It's 100. There we go. So now we're inside this virtual machine running on my laptop. I'm thinking the font might be a little large. Let's try making it a bit smaller. Maybe 14 is good. So the projector here is better than the one I had last time. I think everybody can still see this. So, as I said, we'll install everything in one host. I'm actually going to do something terrible right now. I don't know if I'm still going to be able to show my face in this users group afterwards. A lot of commands in this installation guide are going to require sudo. And while standing here with my laptop, I just want to be able to copy paste.
Does
So,
OpenVNet only work on CentOS?
Probably. The thing is, we only test on CentOS because we don't have enough people to test on other distributions. So, I mean, if you put in the extra work to install it from source or make custom packages, then I'm pretty sure it will work on other distributions as well. But we haven't prepared any way to make it easy, basically.
Would you figure that it would work on the Red Hat Enterprise and on scientific things?
Most likely will. It works on Fedora, that much we've tested. And we haven't tested Enterprise Linux. Or have we? No, I'm actually confused if one of our customers is using it. But most probably it'll work. So the first thing I'm doing here is creating a Yum repository. We have 2 Yum repositories, and under here it says what's in it. So there is the OpenVNet repository, which contains the VNet agent, VNet manager, web API, the VNCTL client, and some common codes that they all use. And OpenVNet itself is an empty package that depends on all of it. Just makes it a little easier to install it all in one host. And then we have another repository with some third-party software that we host. In there we have Ruby and OpenVSwitch, 2 things OpenVNet needs. And we need to pull in some dependencies from IPEL, so we need to install the IPEL repository. But I'm pretty sure I've already done that on this machine. So this is a minimal installation of CentOS, but I have cached all the packages locally because I didn't want to wait for downloading them during the presentation. So yeah, see how fast it is. Am I for time? Oh, yeah, more than enough time. At least I hope this will speed up a little bit. I don't know the shortcut by heart to skip syncing. Should have probably done this I would have done this if Alberto's presentation wasn't so interesting. Yeah, when you started talking about the history of photography and like how all the old cameras worked, and then going up to today, I was like, okay, I gotta hear this.
Yeah, do the history of like networking.
Oh.
What is EPEL?
Sorry?
What is EPEL?
Well, as far as I understand, it's a very popular repository used in CentOS and, well, Red Hat-based distributions, which has a bunch of packages that are not in the main like base and extra repositories. For example, we're going to be installing Redis later. That's going to be from IPEL, I think. But yeah, as I thought, this is already installed. So let's install OpenVNET next. Maybe maximize this while we do it. Yep, so all these packages are already cached locally. Ruby. OpenVSwitch will take a little while actually. So while that's installing, maybe I'll make a bit of a plug for our own personal users group. We have the Wakame users group over here. Actually, well, next event has obviously passed. I did the same presentation there. The next event will be in April, but I'm still asking Broadband Tower to confirm the dates, because this is our sponsors, Broadband Tower. There's, they have one employee who really likes us, and actually he sent an email to us like, hey, won't you do the users group at our company? So I was really happy to get that. And we're actually thinking of changing the name because we want this to be a users group that's not just for our stuff, because that doesn't really fit in the spirit of open source, right? We want this to be a users group that focuses on virtualization and DevOps and that kind of stuff. And if people want to present other stuff not related to Wakame or OpenVNet, then we want to welcome that. And every time when somebody proposes a presentation, they're always like, yeah, we know it's not about Wakame or Axsh OpenVNet. So I think we need to change the name. But we haven't come up with a good one yet. But yeah, right now it's Wakame users group. Next one's going to be in April, and yeah, pretty similar to TLUG, but focused on virtualization and DevOps and stuff. And as we talked about that, we finished installing. So next we're going to install MySQL Server and Redis. So MySQL Server, that's going to be used to store the network state. We're going to keep all the information about what virtual networks we currently have in place. And Redis, that's actually something used by a Ruby library called 0MQ that OpenVNet uses to communicate. Like OpenVNet is also made up of 3 different processes that are on the network, and those processes have to talk to each other. For that, they use DCell. And I don't know how DCell uses Redis. I haven't looked at it in detail, but I know this is a key value storage. And so I assume it's keeping track of like where are all the agents communicating to each other, what are their IDs, what are their IP addresses, etc. So everything is now installed. So we are going to set up OpenVSwitch. Going back to the image on top here, we need a switch to connect our VMs to. So that switch is what we're going to create right now. And since this is a Red Hat-based system, you use etc sysconfig network scripts. You could just use other commands to create it, but this way it will be persistent after reboot. So just going to paste all of that in here. And this data path ID over here that one we're going to need again later. This can be any like hexadecimal number you need it to be. And as is written on the documentation under here, OpenVNet is later going to use this to recognize this OpenV switch. Because let's go back to a slide before. If we go back to this slide for a moment. So there are multiple hypervisor hosts. They all have their own OpenV switch in there, and they also have their own VNA managing it. So OpenVNet needs to know which VNA is taking care of which OpenV switch. And
There's an instance of the agent installed in each hypervisor?
yes,
Yeah.
for redundancy. So if one fails or one machine like has hardware failure, the others are not affected.
Redundancy for the hostings, the VNA running on the host itself.
Yeah. So every hypervisor host has its own VNA. Yeah. And today we have only one host, so we'll have only one VNA. So let's get OpenV switch started. Let's bring it up. So if we look at our IP information now, here is our OpenV switch. This is now a bridge that we can use just like the Linux bridge. Let's start MySQL. We're going to use Ruby to populate the MySQL database, so Ruby has to be in our path. So we are going to use Rake to create the database. Rake is Ruby's version of Make. Like, there will be a Rake file over here with a bunch of tasks in there written in Ruby. And that's what we're going to use to first create the database. And now we create an empty database right now, so let's put some tables in there. If you guys want to see that, doing the terrible thing again. No, not working. So that's the a sneak peek of the OpenVNet database. And all of these are currently empty. We haven't put any data in them yet.
The database itself, there's only one instance.
Yes,
Right.
but MySQL itself has many ways to cluster it and provide high availability. So that is beyond the scope of OpenVNet. So let's start Redis. So OpenVNet can use DCell to communicate. And we start the manager, the thing that's aware of the whole system, and the web API. So we can talk to OpenVNet. Let's have a quick look to see if there were no problems. So this is where the log files are. Looks good. And web API. Yep. We are now listening on this port, and a worker was spawned as well, so everything's fine. So this first vnctl command that we're going to do is to tell OpenVNet which VNA will manage which OpenV switch. So it shows we have a VNA with this node ID, which is, well, VNA. Will manage OpenV switch with this datapad ID. That's the datapad ID we had like up here. This one. And this node ID over here, that's in the same OpenVNet, vna.conf. That's right here. And so let's start up our VNA. So let's have a look if everything went fine here. Yep, we have our VNA running. And we can tell that he found his Open vSwitch, his data path. And actually, yeah, let's maximize for now. Let's get rid of root for a moment. And let's keep an eye on this while we do the demo. Let's log into our VM again. And this is another way we can check if, well, I'll just type it. OVS-VSCTL show. This line right here also shows us that VNA is working, because this means an OpenFlow controller was connected to Open vSwitch. And so we have now taken care of all of this, and the Open vSwitch, but we don't have any VMs yet. So we are going to use LXC to create some containers. And well, I know I've already installed LXC on here, so this can be skipped. Control groups need to be created and mounted for LXC. Oh yeah, let's do the bad thing again. So, there we go. And
What is control group?
that's beyond the scope of this presentation, because control groups is not related to OpenVNET. It's something that LXC needs to be able to create like containers. And containers, for those who don't know, are virtual machines that use the same kernel as the host OS. In a nutshell, it's more complicated than that, but you can think of them as that. Actually, I wouldn't mind doing a presentation on control groups sometimes in the future. Okay. So our sync is needed by LXC to create CentOS containers, but it was installed already. And what this would usually do is do a network install of CentOS. So it would go up, like download everything. But wait, is it? Oh, it's not, okay. Because I had already cached it locally, so it should just copy the root FS. I was worried there for a moment that it was actually going to do a net install, and then we'd have to wait a lot longer. And so we created a VM called inst1. And let's set its root password. Now let's create another one, inst2. Kind of running out of time. I'll have to go over the demonstration itself in faster tempo. So, configuration. So LXC creates a bunch of configuration for these containers, and we're going to get rid of all of it. We're going to create a simple configuration that just says we have a VM that's called inst1. It has a it has a network interface and it has a MAC address. That's pretty much it. And we're going to do the same for inst2. Get out of here, you, and get in here, you. Here's a little bit of mumbo jumbo about the differences between Open vSwitch and Linux Bridge. I'll skip that for right now. This thing doesn't need root anymore. Wait, it does actually, but I'll do. Going to log into our VMs here. Okay. So let's do inst1 over here. Going to leave out the daemon option because I don't want it to be a daemon. I want it to start in the foreground. There we go. And so right now we have made almost everything of this image right here, except for these black lines. We have OpenVSwitch, we have the VMs, we have OpenVNET, but the VMs are not connected to OpenVSwitch quite yet. So these next two commands, they are pretty much the equivalent of taking a network cable and plugging it in.
Mm-hmm.
So inst1, you get added to the bridge, and inst2, you get added as well. And you see OpenVNet noticing like, oh, somebody came onto my OpenVSwitch.
You can also do that from the web interface.
OpenVNet does not have a web interface. Or you mean the web API maybe?
Yeah.
No, you cannot. Like, these still have to be attached manually. Yeah, when you said web interface, I thought a GUI, like web-based. That's why I said it doesn't have one.
You mentioned that they go through the web API, so.
Yeah, so you cannot do this currently from the web API, no.
Because of security measures? Or?
Well, it's more like this is not really the task of the web API. Like it's right now we are still putting together the physical network. That's something that's expected to be in place, and then on top of that you can create virtual networks. And that's the task of the web API. So, let's see. Okay, I have 15 minutes left to do all the demos, so I'm gonna try to be fast. First, we are going to create the simplest network we can imagine, because right now OpenVNet has no networks created yet. So we're going to put these two in a simple network together.
So what did the VM Ethernet ports connect to then?
They are connected to OpenVSwitch, but OpenVNet will not let anything through right now.
Ah, okay.
Like,
and they don't have any IP address yet then?
they don't, no.
Okay.
Like you can see they, well, you can't because my font is too big, but they have actually done a DHCP request and they have failed because there is no DHCP server. So we are going to create a network using VNCTL. If I had more time, I would explain like all the different parameters, but I don't. So
these are commands you're running on each container?
No, I'm running them on the hosts, but actually I could run them from anywhere. These commands just send HTTP requests to the web API.
So what's what identifier for each container specified? What identifies?
Like that's inst1 and inst2.
Oh, so
And
that's CD. Oh,
yeah, well, it's actually if I do this. These are tap devices. Like whenever you create a virtual machine, they will always have a tap device, which is basically like, do we have a network switch anywhere? Can I borrow that device of yours for a moment?
Sure.
Basically, it's this. That's what a tap device is in this context. And so the VM also has a network interface, which is connected to it through, let's say, a virtual network cable. So this tap device gets, well, the technical term is enslaved to OpenVSwitch. It means it is taken and made into a port of OpenVSwitch. Like if I take this device again for a moment, you can think of it as this port, like not being connected. And the command that enslaves it to OpenVSwitch is like taking a soldering iron and putting it in here. But OpenVNet is not yet aware of these interfaces. Like he noticed something was connected to my my OpenV switch, but OpenVNet doesn't know what it is, and OpenVNet is like, hey, I don't know you, you don't get to play, and drops everything that comes from there. So now we tell OpenVNet, hey, this is this interface. It's going to be in this network, and it's going to have this IP address. And we do it for the other one too. So now let's log into our VMs. They do not have IP addresses yet because there is no DHCP server. So we have to assign them manually, because what we have done right now is pretty much plug them into a network. And if you plug them into a physical network without DHCP service, it's going to be the same. So which IP address did we give them? Yeah, 10.100. 0. This one was 10. And there you go. All right. They will be able to ping each other now. This works, but if actually I have the commands in here, it'll be faster to copy paste them. Let's say I do this. I remove the IP address again from inst2, and I give him another one in the same subnet. In a traditional network, this would work, but not here. Like OpenVNet, like we have registered with OpenVNet which IP address this guy has. And if we do this, OpenVNet is like, no, no, you don't have that IP address. If you're gonna play, you gotta play nice. Basically, it's a little less forgiving than a regular network. Well, I'm not sure if that's forgiving, but this is how it works.
Secure is the word.
Maybe, yeah. And so, to keep going so I can show off a bit more, let's add a DHCP server. But these VMs are not aware that they are in a virtual network, so they are going to expect there to be a network interface somewhere else on the network, like another host maybe, that is serving DHCP. And OpenVNet actually doesn't create a real DHCP server, it simulates it in OpenFlow, which could be a presentation on its own. But we are going to add an interface to OpenVNet, which is not real, but simulated.
So what if you're actually using a real DHCP server on this virtual network?
Then you take that DHCP server and you connect it to the network just like we did these VMs. And you don't create.
You have to specify a layer 3 in OpenVNet. Is OpenVNet going to block? I mean, you got to tell OpenVNet that IP is going to be to that.
Yeah, you have to tell it what the IP is going to be.
Which makes it kind of hard to be dynamic.
How is that? Well, can we maybe discuss this further during the Nomikai? So we've created a simulated interface. Now we have to say there is a DHCP server listening on that. And if we do this again, you'll see that we did not get a new tab device. Like, this is all simulated. So, and if this guy whose IP address we changed just now, you already see the DHCP stuff coming up here. It changed back. Still on a little small. But, and we can ping again. So
It was a delay or
Let's see. Let's see.
was there? Let's see, how long did the first packet take? It looks like the first packet did take a little longer, yeah. Sometimes OpenVNet needs to do a little magic, and the first packet will take a little longer to get processed.
are they always picking the SQL server?
No.
MySQL?
VNA has a local cache.
But how does it notice when change takes place?
Either like when the user makes a change, for example, then actually let me get my image over here, not the other image, this one. So when the user makes a change, that means VNet Manager is going to be the first one to notice, then it will push the changes. But let's say a virtual machine gets migrated to another host, then VNA is going to be the first to notice, and VNA will push the changes.
VNA on the host, or whichever one is the master.
Well, the VNA on the host where the VM is migrated from will notice, oh, I don't have this guy anymore, and will let VNMGR know about it. And the VNA that it's migrated to will then say, oh no, I have this new guy.
Do you ever test it with Docker?
Yes, actually, there's this guy who made a blog post about it using Docker and how to install it, and actually more detailed than my current demo because he used multiple hosts. And in Japanese. Muraki-san. So the next one I wanted to show is two networks. So we're going to leave inst1 unchanged, and inst2 is going to move to the new network, and there will be no router. So these networks are not connected to each other. So we create a new network, just like we have done before. And we're giving this a DHCP server as well in the same way. And then to move the instance to the new network, the quick and dirty way is to completely remove inst2 from OpenVNet's database and add it again. But there are no dirty people here, so we're not going to do that. We're going to do it cleaner. And the reason why the quick and dirty way might be attractive is because when you create an interface, it actually does a bunch of stuff behind the scenes. Like it creates a MAC address lease and an IP address lease and a bunch of stuff like that. And we need to go find the IP address lease. So using this interface show command, we have our IP leases, and this ID right here is what we need. In the documentation, it's also described like that. And then we are going to modify our IP lease. So we copy this. Leases. Modify. Going to tell it you're now in this other network, and this is your new IP address. There we go. And so when we do new DHCP request here, because what we did now is basically we pulled out the cable and plugged it in somewhere else. So of course you need to do a new DHCP request. The machine by itself will not be aware of it yet. Shoo. And now we are in the other network, and of course ping will no longer work because that network is not reachable. There is no router to go through to reach it. Let's see, 4 more minutes. Let's put a router in there. Got 4 more minutes for a router? So, and if you think about what is a router, it's a router has multiple network interfaces that each have their own IP. which in many cases ends in a 1. And so we are connecting two networks. So we need two simulated interfaces again, because also this router will be completely simulated. And then we need to create the router itself. And it is perfectly possible to use real routers and real servers and such. We will talk about that on Metanomica if there's interest. So, oops. Something went wrong with my copying. There's one difference from creating a simulated interface for DHCP. That's this line, enable routing. So that's the router for this network, then the router for this network. So now we have the two interfaces up here, but we don't have the router itself yet. We just have two simulated interfaces that don't do anything yet. So first we create a route link. And just like I used the example before of a network like interface existing somewhere that wasn't soldered into a device yet, this is basically the guts of a router that's not soldered to any interfaces yet. So these following commands, they take the interfaces we made and the router guts we made and they solder them together. Because in a production environment, you're going to have many routers and many interfaces. And to OpenVNET, it's all the same in one database, so you have to tell it what belongs together, which Lego cubes will fit into which others. Okay, we're done. We have a route now, but the machines are not aware of it yet because, again, we have just taken a router and plugged in some cables, so the machines don't automatically know this. But if they do another DHCP request, OpenVNET will tell them. Or you could add to the routing table manually, but DHCP is easier.
So this is just a really, really stripped down router that is all you've implemented in software. It doesn't do
that's exactly what it is.
Dynamic routing protocol or anything like that.
No, I haven't actually. I haven't written this myself, so I've done more of the firewall-related stuff. So I don't know like the exact specifications and how much the simulated router can do. But that's a very good question, actually. And
you could certainly take a virtual software and throw it in a container or something like that, and then use that container as your router.
You can, yeah. I've actually done that before on my development environment before this was implemented. Now, so the route is currently in there. We got it from the DHCP, and Bing works again. And you see like our ARP replies from the router are also simulated.
I understand that it doesn't route the packets from one interface to another if you don't enable the routing packets, right? But if we have the same subnet interface of this, and 192.168.0 something and 0 something, if we have the same subnet, then we may have the switch functionality on the machine, correct?
Like you mean like in the first example where, yeah, then it will be just switch functionality, but also it depends on what the physical network looks like, because the machines in a virtual network can be anywhere in the physical network. So it would be possible for inst1 to be here in this room and inst2 to be in California somewhere. And then they would have to be tunneled over like layer 3.
What kind of performance can you get if you've got two machines that want to talk to each other and physically in two different platforms, two different hardware?
That depends all on the physical network. If you've got like a fiber cable between them, you're going to get a really high performance. And if it's like some crummy Wi-Fi, then
where does the bottleneck usually end up being?
That's in the hardware. Like we've had one sponsor do a bunch of tests, and I don't have the actual data, but their conclusion was OpenVNet is extremely fast, and the bottleneck is still the hardware.
So is the Ruby code running in kernel mode?
I don't know. I will have to ask the lead developer, but I think it's userland actually. I think it's userland.
But
Yeah.
OpenVNet, the bridge, software bridge itself is kernel mode.
Yes. OpenVNet uses the Trema framework to like implement an OpenFlow controller, and then uses the OpenFlow protocol to talk to the bridge. So the actual like system calls to go from userland to kernel modes, they are they are done by OpenFlow. And now I've answered the question I said I didn't know before. So if that's the case, then yeah, OpenVNet must be running in userland completely.
Can you connect your, I guess, the vSwitch to the physical network?
Yes.
Like to get these VM machines out access to the internet?
Yes, you can. Like, well, to give them access to the internet, well, you would use VNet Edge, which I demoed at TLUG before with like gaming animations. But you could also, instead of virtual machines, connect a physical machine to this. Because I mentioned how you create a virtual interface that's then soldered to Open vSwitch. You could do the exact same thing with a physical interface. You could take ETH0 and enslave it to Open vSwitch, and then take another physical machine and connect the cable to that ETH0. And actually, at Axsh we are planning to do that in a hackathon. I know we're out of time, so this will be the very last thing, and then we can talk more to the guy. Going down here to the news. Like this hackathon right here is where we are going to do exactly that. We are going to take like Raspberry Pis and Edison devices, and we are going to create physical Open vSwitches that we can connect laptops, etc. to solve the confusion of what is like the virtual network, what is the physical network. And this page will be in English if your browser settings are English, by the way. But it's full, and we have quite a few people on the waiting list already. But since it's so successful, maybe we'll do this again sometime in the future. But okay, I've gone 5 minutes too long already, so thank you for listening. I wish I could.
We will be heading out for Nijikai, so if anybody wants to come along for a few beers. And I forgot where was the place we went last time. Does anybody